So integration technique number one, substitution. It's kind of reverse of the chain rule. It's called U substitution, U as in the letter U, because we use the letter U. Being able to find an antiderivative function is very useful. If we know the antiderivative of f of x, then evaluating the definite integral from 2 to 5 of f of x dx is a simple process. If we can't find the antiderivative, then this becomes more difficult or even impossible. So far, we found the antiderivative by guessing and checking. It's like factoring, right? So if guessing and checking works for you, by all means continue to do it. This is just giving you something to fall back on. Right? So like solving a quadratic, it's like the quadratic formula, or it's like the over the rainbow method of factoring. So there's just, I can't factor this. This gives you something to fall back. So if I can't see what the antiderivative is, this gives you a process to follow. So we'll introduce you to techniques, and that's basically the next few days is these techniques that will help you when guessing and checking becomes too difficult. Integration technique number one, substitution. Use substitution to determine each of the following. All right, so here's how, you can probably do this one, right? But here's a systematic method to do it if you can't. So we're going to say, I got a problem with this x squared plus 1 on the bottom. I'm not really sure what to do with this. And what we say is this. Let u equal x squared plus 1. Which means that du, well, du by dx is equal to what? What's the derivative with respect to x? 2x. Which means du is equal to 2x dx. Oh, that's kind of handy. Look, we have a 2x dx, right? So we can replace that with du. So if we wanted to, we could rewrite this and say, well, it's the integral 1 over x squared plus 1, 2x dx. Look, 2x dx, 2x dx, 2x dx, 2x dx. But x squared plus 1, well, that's u. So this becomes the integral of 1 over u du. All right, now that's easy, right? What's the integral of 1 over u du? Ln u, with absolute value symbols around it. I do not want to lose half marks on quizzes by leaving those off. Okay, so that's equal to ln absolute value of u plus c. Don't want to lose marks by leaving plus c's off of indefinite integrals, right? So if you're doing a definite integral, it's not so important you put the plus c. With indefinite integral. So this is general, it's like a general antiderivative, right? So you need that constant. But we're not solving this for you. We're doing this for me. No. So what's u? So u is x squared plus 1. Right? So at the end, when we're finished, right? So we substitute in to make it a simpler problem, right? One of George Polly's problem-solving methods, right? Solve a simpler problem. All right, let's replace the u with the, the x squared plus 1 with the u. Okay, so it's the ln of the absolute value of, okay, u is x squared plus 1 plus c. All right, and that's it. All right, so let's see how this works with the next one. And again, we could probably figure this out. Okay, you know, and it's fine if you can do it that way. If you can guess and check, by all means, go ahead. The important part of guess and check is what? The check, right? You want to make sure that it's correct. If you can't guess and check, then all right. So same idea, right? We said, well. Complicated. Well, here's the thing. If I take the derivative of 4x cubed plus 6, I'm going to get 12x squared. All right, and I need an x squared, right? Okay, so let's do that. So this is the thing. So let u equal 4x cubed plus 6.
You always want to substitute for the denominator?
Well, no. You want to substitute for the expression that you sort of think of this as chain rule, and sort of like that's the inner function, the 4x cubed plus 6. Right? When I take the derivative of that, I'm going to get a 12x squared, and I want an x squared. Okay. So when we do the derivative, what do we get? So we won't do this anymore, right? We'll just go straight to this. Okay, so we're just going to say du is equal to, so du is equal to, what's this? 12x squared dx. All right, but the problem is our problem has 3x squared dx. So how do I make a 3x squared dx into a 12x? Or how do I make a 12x squared dx, rather, into a 3x squared dx? Divide by 4. So if we say, well, here's what I'm going to do. I'm going to take 1/4 of both sides. So 1/4 du is going to be equal to 3x squared dx. Which means, now think about when I go to write this, and we'll split it out a few times. So I've got 1 over 4x cubed plus 6, and then I've got 3x squared dx. Okay, but the last time I'm going to split it out like that. I just want to see, what are we doing, right? We're going to replace 3x squared dx, right? So it's like, I got 12x squared dx. I don't need that. I need a 3x squared dx. So I'm going to take 1/4 of it. So we're going to replace this with, well, what's it equal to? 1/4 du. We're going to replace this with a u. So I have the integral 1 over u, 1/4 du. Okay. Now, make sure that makes sense to you. You can see that, okay, yeah, I get what you're doing here. All right, we got a 12x squared, but I don't want that. I want a 3x squared. All right, so to get a 3x squared, you take 1/4 of both sides. So I can replace 3x squared dx with 1/4 du. I can replace the 4x cubed plus 6 with u, because that's what I started out by saying. Okay, the 1/4 being a constant can come out front. So 1/4 integral 1 over u du. All right, well, can we just do that?
Yes.
Yeah, okay. Oh, we need equal signs all the way along here. Equals, 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 equals. So 1/4, now, you drop the integral sign, right, because we're going to just take the integral, which is ln u, with absolute value symbols around it, and on the end, plus c. And then, as the final step, because it was never about you, sorry.
You're a roti over.
Yeah, you think it's always about you. So, what is it? So it's 1/4 ln of 4x cubed plus 6 plus c. Now, maybe you wouldn't have figured that one out yourself. Right. But if you can, so when you're doing integrals on the test, exams, whatever, if you can figure it out, you can guess and check it, by all means, go ahead and do that, right? Okay, so it's like factoring. So I don't care how you do the integral, unless the question says use substitution to determine the integral, then you're going to have to show that. Okay, next one. So, what's u going to be?
Cosine theta.
Yeah, cosine theta.
Okay, so this is the
Right? This is all about the 1 over u. Right? So if I can get this as 1 over u, right? Because otherwise you got to do sort of an anti-quotient rule.
So I was trying to get 1 over u is your target.
Yeah, if I can get it as 1 over u, because then I know it's just ln absolute value of u.
Okay.
Okay. So in this case, yeah.
Could you like make it into a tan theta?
Sine over cos. You could, but that's not the point of this. But what's the antiderivative of tan? So what do you get? So you make it a tan. It's not like the derivative of tan, that's sec squared. It's like I need the derivative of something to give me tan theta. You don't have that on your formula sheet, do you? So, you know, like yeah, otherwise turn it into tan, but it's really, it's not so easy. Okay, so let u equal cosine theta. Then what's du? Yeah, sorry. So du is equal to negative sine theta. It'd be an x if it weren't a theta. So negative sine theta d theta.
Oh, very good.
Now at this point you say, I have a sine theta d theta. So if I make this sine theta d theta, then I'm going to make this a negative du. So you can see now the sine theta d theta can be replaced with negative du. Make sense?
Right.
So basically what I want to do at this point is match this. So now I go the integral of, okay, so the cos theta, that's 1 over u. This sine theta d theta becomes negative du. Okay, what do we do with the negative? Pull it out front, right? So it's a negative 1 over u du. So negative is a constant, right? It's just negative 1. All right, and now, so that's equal to the negative ln absolute value of u, goes on the end, plus c. Which is, because it's not about u, so what's u? Cos theta. Yeah. So now we just replace the u with the cos theta as the last step, plus c. Okay. Now if you do the derivative of that, you should get sine theta over cos theta, right? What do you get? Well, so I've got negative ln, so it's going to be 1 over cos theta times negative sine theta, or negative sine theta over cos theta, and it's the negative of negative sine theta over cos theta, which is sine theta over cos theta. Okay? Same deal with any of these, right? If you take the derivative of any of these, they will come back to be what it is. Okay, moving away from, I have some notes on differentials here that I don't know if I'm not gonna, we'll mention as we go along. Okay, so what's u?
You could just make x u.
So what's the derivative of ln?
1 over.
Okay, so then u should be ln x, right? Because then du is 1 over x dx. Ah, look, see, we can split that out as to, so u is equal to ln x, du is 1 over x dx, so that's this guy. So the thing that I just, not exactly circled, but whatever, indicated, can be replaced with du. And so the idea is what? Well, the idea is we want to write this in terms of u and du, right? No x's. You're not allowed to have x's in there at this point. Yep.
How did you know to make u ln x and not x?
Well, it's either that or I have to take the derivative of 1 over x, right? So I take the derivative of 1 over x, then I get like negative x, negative 2, and I don't have that there, right? So you're looking at which one, right? I got two choices here, right? Well, if I make x u, then the derivative of u is just 1, and then, but I don't have a ln x, right? So it's like, what can I replace? So I need to replace this either ln x dx, so I either need the derivative of something as ln x dx, or I need the derivative of something as 1 over x dx. Okay, and the something in this case is the ln u. Okay, so we've got the integral of u du. What's the integral of u?
U squared.
Yeah, with a half in front and a c on the end. All right, but it's not about blah, blah, blah. So 1/2 ln x squared plus c, and I suppose you could write it as 1/2 ln squared x plus c.
Can't you bring the 2 down? Oh, wait, no. Okay, it's not on the x, it's on the whole thing, right? Squared.
It's the ln of x, with that quantity that's being squared. It's not the x that's being squared.
Okay, so you can't bring it down.
No, you can't make it a 2 ln x. All right, one moment, please. So here's the other thing I have to say. Because u substitution is like reversing the chain law, what's the inner function here? 4 theta, 4 times theta, right? Okay, so we let u equal 4 theta. What's du? 4 d theta, right? Right, du by d theta is equal to 4. We're going to kind of skip that step now, right? Just go to du's 4 d theta. Now, do you see a 4 d theta there that I can replace? No, so what do I want to do? So 1/4 du is equal to d theta. Okay, so the d theta can be replaced by 1/4 du.
Got the,
So integral
hey,
sine.
got the, what's on the line, theta, got D0.
Oh. Don't do. Okay, sine what? Sine u, right? So the 4 theta is replaced by u. The d theta is replaced by what? 1/4 du. Okay, so the 1/4 constant, I'm just going to start writing that out front. Okay, so I'm replacing d theta with 1/4 du. The 1/4 being a constant just gets written in front. You do so 2 lines if you like, right? You can write it as sine u 1/4 du and then pull the 1/4 out front. Okay, so here I'll redo it doing it that way. So you have options. So equals the integral of sine u 1/4 du. So I'm just bracketing that so we realize the d theta became a 1/4 du. Okay, equals 1/4 integral sine u du. 1/4. Okay, what's the integral of sine u?
U.
What's the derivative of cos? Minus sine. So what's the integral of sine?
Oh, missing.
Okay, so negative 1/4 cos u plus c, negative 1/4 cos 4 theta plus c. Okay, the last one, right? Now, I mean, if I gave you this one on the quiz, you would have got it. Like, you might have forgot the negative sign, but, you know.
Half mark.
Yeah, kind of half mark. 2 plus sine x to the 10th cos x. All right, so is the cos x going to give us a 2 plus sine x to the 10th? If we take not likely, right? So, but 2 plus sine x to the 10th, we will get a cos x out of it, right? Because it'll come out as the inside function. So what's u?
2 plus sine x.
Yeah, so let u equal 2 plus sine x.
Try to make the function u if possible.
So what's du?
U is
Cos x dx, right? Right? Because derivative of 2 is 0. So you got 0 plus, derivative of sine is cos. Oh look, cos x dx. It's hanging off the end there, right? So now, what are we doing? We're doing the integral of what? U to the 10th du. So it should be justifiable. Every time you look at that second or third line, you should be able to see, all right, so u to the 10th, well, that's obvious that u is 2 plus sine x. And then du, well, that just replaced cos x dx. And you've got justification for doing that over on the side there. Right? Du is cos x dx. Okay, what's the antiderivative of u to the 10th? 1/11th u to the 11th. Right? Remember, the derivative is going to be 11 times, so we got to divide by. Remember the anti-power rule of u to the n is 1 over m plus 1 u, or x 1 over n plus 1 x to the n plus 1. All right, fill it in. What's u? 2 plus sine x. 11 plus c. Right? So when you think of it this way, it's not so bad. More. E root x over root x. Yeah, so u is equal to root x, right? It's the thing on the bottom, and so let u equal root x. What's du? of root x. Half x to the negative a half, right? Just plain old power rule, right? Root x is x to the half. Power rule, derivative 1/2 x to the negative 1/2, which is 1 over 2 root x. Now, what's the problem? Do I have a 2 root x somewhere in there? No. So I want to get rid of this. So how do I do that? How do I get rid of the 2? Multiply by 2.
I think you forgot for the x.
I did. You're right. Right again. All right. Okay, so now we've got a replacement for dx over root x, right? Or 1 over x dx. Okay, so this is equal to e to the what? E to the u, right? Because we can't have an x in here anymore.
Thinking the EU Brexit to.
What? Oh, you think they're going to vote for?
Yeah, they are.
Want to put money on that?
Do it.
Later, after the video. There's no gambling in mathematics. Gambling has nothing to do with mathematics, except it has everything to do with mathematics. The branch of probability came about due to gambling. Right? It's like they're trying to figure out. Because if you knew and they didn't, then you were going to win more than they did. Anyways, so e to the u du. What's the derivative of e to the u du? E to the u plus c. What's e to the u? E to the root x plus c. Oh, wait, we forgot. This is a 2 du. Clean up on aisle 3. So 2 integral e to the u du. Okay, so equals 2 e to the u plus c equals 2 e to the root x plus c. Sorry, we went to all this trouble of getting this so that this could be replaced by this, and in doing so, we just kicked the constant out front and the du there. So what's c? It's any constant. So c, 2c, no big difference. Sometimes people might write it as c1 and then c2, like or c and then c sub 1. Ooh, it's a different constant, which is twice the constant, it's twice any arbitrary constant. I've never really seen the point, well, okay, so, I could write it as 2c, and then I could write it as, so we could do this, okay, which then gives us this, which then gives us a different constant, right? So that's doable if you prefer that. So you might see that occasionally. So what's the integral of this is e to the u plus c, but the whole thing is being multiplied by 2, so it's 2e, now u gets replaced by root x, plus, well, if you're multiplying by 2, you multiplied the constant by 2, and so it's now a different constant, but if I arbitrarily chose 5, I could arbitrarily write this with a 25 or a 10 or a 17.2 or a pi or whatever. Okay, what's u? So sometimes it's pretty easy to figure out, right? It's just that's the inside function. And the derivative of 15x cubed is going to be 45x squared, right? So du is 45x squared dx, but I've got an x squared dx, so I need to get rid of that 45. So 1/45 du is equal to x squared dx. So this circled stuff will be replaced with 1/45 du. So the 1/45 coming out front, I have the square root of u du. Make sense? Did the constant this time? What? Okay. What's the antiderivative? So this is u to the 1/2, which is going to become what? Well, it's going to be u to the 3/2. We got to get rid of the 3/2. So it's going to be 2/3. 2/3 u to the 3/2 plus c. Yeah. Yeah. Good. You guys are learning. Track mistakes early. Don't wait till the end. Okay, so that's 2/135 u to the 3/2 plus c1. Some different constant, which is 1/45 of whatever your original constant was. Except we're not done, because it's not u. It's 2/135 15x cubed plus 7 to the 3/2 plus c1.
Oh, yeah.
Okay, so if you take the derivative of that, you're going to go 3/2 times 2/135, which gives you 3/135, which is 1/45, times 45x squared. When you pull that out, it should just give you the original. Okay, so if you do the, and this is, yeah, I suppose you could have sussed that out. You probably would have had difficulty getting the 2/135 though, right? If you were trying to figure it out on your own. What do I need for a constant there? Okay, this makes it a little more systematic, and sort of like the 1/45 is pretty easy to figure out, and then the 2/3 u to the 3/2 to end up with that constant. Okay, what's u?
Just one.
Ln x. What's du?
1/x. Dx.
1/x dx. Okay, so that gives me this, right? What I just circled will be replaced with du. The 3 is a constant, so the 3 can come out front. So 3 integral of 1/u du. Okay, so just make sure that line looks good. Okay, 3 constant came out front, 1/ln x, but ln x is now u, so 1/u, and the dx over x got replaced with du. All right, what's the derivative, or what's the antiderivative of 1/u? Ln absolute value of u plus c. And what's u? So 3 ln x plus 3. No, oh, we better make sure that ln x is positive. So that's equals 3 ln x. Okay, and if you write the c and it just stays as a c, that's fine. Yeah, it's a different c than it was before, but it's just an arbitrary constant anyways. So it might just be a slightly different arbitrary constant. Yep. What's ln of ln? ln x is g. No, it can be negative. It's the exponent you raise e to get x. And then, okay, in general, using substitution undoes the chain rule. It's like burying the lead, right? This could have been the first thing we led with. Substitution. So if the integral of f of g of x times g prime of x dx, right? Which means if we can see that the derivative of this inner function is out there in some form, right? May require a constant to make it the same. Then we let u equal g of x. Then du by dx is g prime of x, which means du is g prime of x dx, right? So this becomes du, right? And this becomes u, so that becomes f of u du. Okay? So now it's a function in a different variable, but it's one whose antiderivative is easy to figure out. Okay, and as we move into these, they become a little bit tougher to kind of guess and check on. Okay, so it helps to have something that's a little more systematic way of doing this. Okay, so we don't have a ton of room across here, so let u equal, so what's the inner function? 2 minus ln x. 2x minus ln x. What's du? So 2 minus 1 over x dx. Ah, okay. So easy peasy now, right? Okay. It wasn't shining brightly yesterday.
This guy.
Okay, so the sine of 2x minus ln x becomes the sine of u. The 2 minus 1 over x dx becomes du. So we've got the integral of sine u du, which is simply cos u plus c. Wouldn't it be negative cos u? Yes, it would. I was waiting for that. Oops. So negative cos 2x minus ln x plus c. Okay, so final step is just to replace. Okay. Now again, I mean, you might have seen that the derivative of 2x minus ln x would be the 2 minus 1 over x, and just said, all right, I just need to get something whose derivative is the sine of that thing, and just written negative cos of that plus c. So again, if you can guess and check, by all means, okay, unless it specifically says use substitution to algebraically determine, and then you should show that. Then you should show that. Speaking of u, what's u in this one?
30x plus 5.
Is that the inner function?
Wait, no. 3x squared plus x.
Yeah, 3x squared plus x, right? So we know we're going to have an e to the 3x squared plus x, because the derivative of that is e to the 3x squared plus x. And then there's going to be a 6x plus 1, which we need to turn into a 30x plus 5, but we'll do that step by step. So let u equal 3x squared plus x. So what's du? Okay.
Is 6x plus 1.
Plus 1 dx. Make sure there's brackets around the 6x plus 1, right? Don't just write 6x plus 1 dx, because then that's really 6x plus 1 dx, not 6x plus 1 dx. All right, but I want 30x plus 5. How am I going to get that? So multiply both sides by 5. Okay, so now I have 30x plus 5 dx. That can be replaced with 5 du. Okay, so here, let's come down here. So go integral of e to the u times 5 du. Okay, so I'm just doing this in kind of 2 steps. Now I'll move the 5 out front as a constant, right? Just to remind you that these underlying things can be replaced by 5 du, right? It's the same as 5 du, which is equal to 5 integral of e to the u du. What's the integral of e to the u? E to the u? EU. Will they stay or will they go?
Wait, is there?
When is the vote? Is it before school is over or after? What do we say u was? 3x squared plus x. Okay, so we've got 5e to the 3x squared plus x plus c. Who's u? 1 minus 3x squared, right? The inner function. Because we know we're going to get a negative 6x out of it, right?
Yes.
Okay. So let u equal 1 minus 3x squared. Not the square root of 1 minus 3x squared, right? Just 1 minus 3x squared. That's the inner function. Okay, what's du?
Negative 6x.
So du is negative 6x dx. But what do I want? I don't want negative 6x.
You want positive 3x?
I want positive 3x. How am I going to make it positive?
Negative over 2.
Yeah, so negative 1/2. Multiply both sides by negative, so negative 1/2 du is equal to 3x dx. Okay, so here's the 3x dx. Okay, we're going to replace that with negative 1/2. That's a constant. So negative 1/2. That's the negative 1/2. It's constant, so it comes out here. 1 over root u du. Okay, makes sense. Substitution makes sense to you. Okay, what's the, so that's u to the negative 1/2, right? So maybe we just sort of kick up here and say, I'm trying to do the antiderivative of u to the negative 1/2. So what do I got to add 1 to it? So negative 1/2 plus 1, right? And then what? So I got to multiply it by, yeah, 2, right? So. Okay, so we have negative 1/2 times 2 u to the 1/2 plus c. So negative u to the 1/2 plus c1. Different constant if you want, right? If you just leave it as a c, I'm not going to ding you for that. Equals negative, okay, what's u? 1 minus 3x squared. Yep. Yeah, C1. Different C. Negative 1/2 times 2 is negative 1. So negative u to the 1/2. Yeah, plus c. So now it's c1. I'm never gonna write the constant as negative 1/2 of the original constant. I'm just gonna say it's another constant, which is negative 1/2 times the original constant. What's the original constant? Any number. What's negative 1/2 times any number? Any number. Yeah, so I don't mind if you just go straight C's all the way down, right? Just saying, yeah, it's a different constant. I don't mind if you do a C1 to say, hey, it's a different constant. Which, and if somebody says, well, C1 is okay, it's negative 1/2 times C. It doesn't matter because it's any arbitrary constant. Okay, so doing negative 1/2 of any arbitrary constant. Okay, we definitely have to evaluate. So this is a definite integral. Okay, so a definite integral will be a value. which is what? The difference between the area above and below the x-axis for this particular curve in this particular interval, right? Which at this point we don't care about it. It's a number, right? Could be positive, could be negative. If it's negative, there's more area below than above, and vice versa. Okay, so we have to do, so what we're going to do is we can just do the general, the indefinite integral, right? So we can do the indefinite integral. So we start off, what's my inner function is going to be 1, so let u equal 1 plus 2x cubed. Okay, then what's du? Okay, so u is 1 plus 2x cubed, du is 6x squared. I don't want 6x squared dx, I want x squared dx. So I multiply both sides by 1/6.
Why'd you put bracket around 1 plus 2x?
Yeah, I didn't need to.
Okay.
Yeah, well, it's just saying it's this quantity, right? Because when we go to replace it, it's going to be u to the 5th, yeah, and it's not going to matter. You won't have brackets there. Okay, so we could do a general antiderivative, right? Or sorry, an indefinite integral, the indefinite integral of, so this will be what? Well, u to the 5th du, which will be 1/6 u to the 6th.
1/6.
Oh, right, 1/6, okay, hang on. All right. Yeah, 1/6 du. 1/6 du. Yeah, factor out the 1/6, so that's 1/6 integral of u to the 5th du. Now, at this point, okay, before we do this, let's go to the definite, back to the definite integral, right? We're going to evaluate it. Now, here's the thing. What we don't have to do here is figure out the indefinite integral, put the x back into it, and then evaluate it from x being 0 to 1, right? Instead, we could do this. So, okay, I want to evaluate this over some interval, right? What interval? Well, I want x equals 0. So I say this, when x equals 0, what's u equal to? Well, so u is 1 plus 2x cubed, right? So it's going to be 1 plus 2 times 0 cubed. So when x is 0, u, let's get the brackets off of there. So u equals 1. When x is equal to 1, okay, so I figured out my lower bound of integration was x equals 0 or u equals 1 to x equals 1 or u is equal to 3. So now what we can do is this. We can do the definite integral from 1 to 3, okay, 1/6 u to the 5th du. Now u to the 5th du is going to be much simpler than the x, right? Working out the x. Okay, so when x is 0, lower bound of 0, we substitute in, we get u is 1. When x is 1, we substitute in, when x equals 1, u is equal to 3. So if I'm going to do the definite integral with respect to u, I have to do it from the bounds of 1 to 3, not 0 to 1, right? 0 to 1 is for x's. This is for u's.
Oh.
Okay? Now, it's a lot easier to work this out. Okay? This will be 1/6 of 1/6 of u to the 6th, evaluated from 3 to 1. Okay? So that's how we show this, that we're going to evaluate this from 3 to 1. Actually, let me round bracket, clean this up a bit. So 1/6 u to the 6th, evaluated. Okay. Right? Because it's going to be a value.
Go and do plus c.
You don't need the plus c because now you're doing a definite integral. So if you had the plus c, it'd be a plus c on one side and minus c. So when we evaluate definite integrals, we don't bring c in. No c. You see?
Oh, you see?
Okay, so evaluating definite integral, we've got that 1/6 in front, and then we've got 1/6 times 3 to the power of 6 minus 1/6 times 1 to the power of 6.
Can you not put the 1/6 in?
You can if you want.
Okay.
I mean, in the end, it's got to come in there.
Yeah.
So I just figured it's probably easier to take whatever's left and divide it by 6 than it is to get whatever and divide by 36, but I don't know. Okay, so 3 to the 6th.
Oh,
Okay, so it's 3, 9, 27. I don't know how many people did 9 was 3 cubed. I don't know if it was this class or 30-1. Somewhere there was it had to be 30-1. 30-1s, and it was like 1 over 9, and then they changed that. It became 1 over 3 cubed, and I'm like, no, it's not cubed. Okay, so this is equal to 728 over 36. Okay, ultimately. No point in dividing the 6 or simplifying 729 over 6 because you got a common denominator of 1/6
You
or
can also
1/36.
do it by taking one more step over there. And
Oh, it would be, yeah. So you could also, let's call it 1/36 u to the 6th. And then go 1/36, 1 plus 2x cubed to the 6, evaluated from,
Yeah.
So doing that would get you the same, right? But the whole idea is, look, if we're doing u substitution, we've made a much simpler expression here than this.
Yeah.
So we don't want to do that. Yeah, you can, right? And then you say, oh, that test was so long, I ran out of time. Because you chose to do something you didn't need to do. Right? So basic idea, when you're doing a definite integral, you're using u substitution is, you can work this down as an indefinite, get your new bounds of integration, right, for u instead of x, right, when x is 0. So this is x is 0 to x is 1, but it's u is 1 to u is 3. All right, part B, integration technique number 1, substitution. All right, might as well finish this off because it's like
Yeah.
4 more examples, right?
You skipped 2.
Did I? Oh, there's more on the other page. Oh, look at that. Okay, definitely back up a page. What is u?
on X.
Yeah, ln x, right? The inner function, ln x. Okay, I don't know. Let's go over here and do this over here. So what's du?
1 over X and dx.
1 over x dx. Oh, look, that's this. All right, now. Okay, we're going from e to the 4th. So at this point, we can do our bounds of integration, right? Yeah. So taking this, we say when x is equal to e, u is equal to ln e. So what's u? The ln of e, 1.
Oh, you're not gonna, okay.
Well, I am, but I'm just doing this over here.
Order, okay.
So what's u? 4. Right? That's a lot easier to plug in to something which is not going to have lns in there, right, than it is to plug in e's and, right? I'm just doing, so now this becomes the integral from 1 to 4, the definite integral from 1 to 4 of what? 1 over root u du. Right? So we had 1 over ln x becomes 1 over root u du, right? And we're doing that from 1 to 4. All right, what's the antiderivative? U to the negative 1/2 becomes 1. 2u to the half. Okay, so you end up with a half times 2, which is 1, u to the negative 1/2, which is what we're going to have here. So this is 2u to the 1/2 evaluated from 4 to 1. Okay, it's going to be almost trivial, right? Because we got square root of 4. So that's equal to 2 times 4 to the 1/2 minus 2 times 1 to the 1/2. And ultimately, it's just going to work out to 2. Which is a lot easier than doing the square root of the ln of e, whatever, right? So, the idea is this, right? We're going to use u substitution. So we work out u, we work out du, and then we say, but wait, this is a definite integral. You have bounds when x is e. So you go back in, you substitute in when x is e, get your lower bound for u, upper bound for u, and away you go. All right, and then there's another one down here. What's u? Theta squared plus pi over 2. What's du? 2 theta d theta. Okay, I don't have a 2 theta d theta. What do I got? It's got a 4 theta d theta. How do I turn 2 theta d theta into 4 theta d theta? So 2 du is equal to 4 theta d theta. Box that up. Now we say, oh, okay, when theta was 0, then what's u? So when theta is 0, u is pi over 2. And we just plug in, right? Because we have an expression for u. And when theta is root pi, u is equal to root pi quantity squared plus pi over 2. So what's that equal to? 3 pi over 2. Okay, so we're working out a definite integral. It's got bounds. We're using u substitution. We let u equal and so on. And then we work out our new bounds of integration, right? Because now we're going to do everything in terms of u. So this is equal to the integral from pi over 2 to 3 pi over 2 of sine u times 2 du. Okay, so there's sine, this is u, 4 theta d theta, that's 2 du. Okay, so the 2 we can kick out front. Pi over 2 to 3 pi over 2 sine u du. What's the, doing this one all day. Antiderivative of sine? Negative cos. Okay. So minus cos u, so 2. So 2 negative cos, quite that small. Negative cos u evaluated from, change that to brackets, 3 pi over 2, upper bound pi over 2. Okay, so we just plug in. We've got negative cos 3 pi over 2 minus negative cos pi over 2. All right, what's the cosine of 3 pi over 2? 0. Plus, what's the cosine of pi over 2? 0. There's nothing to this. So what does that say? Yeah, the upper area and the lower area must be the same, right? So if you graphed this from 0 to root pi of 4 blah, 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 right, you're probably going to end up, not probably, you end up with an area above the axis that's equal to the area below the axis. Okay. That's all it's telling us. All right, what do we got? 5 more? Might as well drag this out and then have a work period tomorrow. Or we can stop now and do the other. Drag it out. I agree. Just make one video that's 2 hours long. Well, we're at 56:12 right now. How much time do we have? Still got 16 minutes. Okay, determinate back to definite integrals, but with a twist. So what's the twist? So the problem is here we have a binomial denominator, right? Now, if you had a monomial denominator, I don't know if you can squeeze this in on your page. Yeah, you can. So if the denominator were monomial, if denom were monomial, and let's say we wanted to work out this, the integral of x plus 1 over x dx, you could just split this out, right? You could write it as the integral of x over x dx plus the integral of 1 over x dx, right? You can just simplify it down, right? Or you might just go directly to this and say it's the integral of 1 plus 1 over x dx, right? Which is easy to do, right? And that's easy to do because it's just x plus ln x. X plus ln, and when I say x, I mean absolute value of x, plus c, right? So monomial denominator is easy. Just divide each of the things up above it, right? If you got a sum or got a binomial or trinomial up top, just divide. The problem here is, can't do that. The monomial is in the denominator. Okay, so here's how we do a monomial denominator. We let u equal x minus 4. Okay, now we add one other little extra step here, right? Which is, fine, that's going to be a u, but what's this going to be? So we got to solve this for x. So x is equal to u plus 4. So what I'm going to do is turn a binomial denominator, right? So a monomial over a binomial, I'm going to turn it into a binomial over a monomial, and then do it just the way I just showed you, right? Right? Like life is easy. Okay, but what's du? 1 dx, right, or just dx. So du is dx. We see dx, we replace it with du, vice versa, whatever. So this becomes, so x, well, that's u plus 4. X minus 4, that's u, dx, or sorry, dx, that's du. So we do the integral. If you like the one step, it'll be 1 plus 4 over u du. Right, so we're just dividing, or you can split it up into the sum of two different integrals, right? Do it as the integral of u over u plus the integral of 4 over u. Your choice. And what's that? Well, it's just u plus 4 times the ln of u. And when I say the ln of u, I of course mean the absolute value, plus c. And now we substitute back in u. What's u? U is x minus 4. So x minus 4 plus 4 times the ln of the absolute value of x minus 4 plus c. And then I could do one more line. I can write one more line and you can do, oh, you should, why are you doing that?
Yeah.
All right, what's the difference? The negative 4 is a constant, right? So I've got x minus 4 plus 4 plus some arbitrary constant. Well, okay, negative 4 is a constant. So I can just combine them into C1, which if you really want, you'd write C1 is equal to big C plus 4. Oh, because I'm getting rid of that minus 4. I can't just... Okay, but you can just replace it with some other arbitrary constant. So you might see that, right? You might get this, and then you don't see that. It's like, the answer's not there, right? Because I got a minus 4, and the answer doesn't have a minus 4. Well, minus 4 is just a constant, so all you've done is replace. All right, what are we going to do here? Just going to clean that off. We already saw it. So let u equal 6 minus x, right? So I don't want to have a binomial denominator, right? I want a monomial denominator. I'm going to replace the denominator with a monomial. Okay, but, and the thing is, okay, look, I don't need to replace an x anywhere, right? So I don't need to solve this for x. So what's du? So negative dx. Okay, well, I don't have a negative, I've got like an 8, but the 8 can go out front, so negative du is equal to dx. So the 8, that can go out front, 1 over u, negative du, so negative 8 go. So the 8 being a constant, you could leave the 8 in there, it doesn't really matter, right? You can move it out front. So either way, it's not going to make any difference in the end. So this will be negative 8 ln absolute value of u plus c. But we're not done because you can't leave a u. Negative 8 ln, what's u? 6 minus x plus c. Okay, we got 3 more, 10 minutes. Maybe do it.
Hey, hang on. Brett, hang on. Hold up.
Yeah. Okay. I hope it's finishing before the bell.
So on the first one, why did you get rid of the minus 4 again?
Because I can. So it's a constant, right?
Yeah.
So this is just a different constant, which is 4 less than the original constant.
Oh,
What I wanted you to just see was if you get a minus 4 and you're looking at answers, it's like, there's no negative 4 in there, right? Like, I don't even know what to choose here. Then you'll remember and say, oh, but it's negative 4 plus an arbitrary constant, which just means my new arbitrary constant, which you might still see as a c, not a little c1 or c2. Okay? All right. Again, right, the idea is I want to replace this binomial denominator with a monomial. So we're going to let u equal x plus 1. Now, I do have an x up here, so I need x. So what's x equal to? All right, so here's all the info I need. U is going to replace x plus 1. X is equal to u minus 1, right? Because I got an x up here, so I can't leave an x, can't mix x's and u's. And du is equal to dx. So it's the integral of 2 times x. Well, x is u minus 1 over u squared du. Now, I can pull the 2 out front. And I can split this up, right? I can write it as u over u squared minus 1 over u squared, right? And those are easy to work out. So now that I've got a monomial denominator, right? I got a binomial up top. So I got 2. So I can go u over u squared du minus the integral of 1 over u squared. I can split it up like that, or I could write it as 1 over u minus 1 all over u squared. Right? I don't know. I think it might be easier to just separate this out. So this is 1 over u du minus, and this is still, well, let's write this as u to the negative 2 maybe. All right, what's the integral of 1 over u? It's going to be the ln of the absolute value of u. And what's the integral of u to the negative 2? We add 1 to that. But they're going to multiply by a negative, so this is going to become a positive here, right? So it's going to be plus. And extend the page, not about u. So u is x plus 1. So 2, I can leave the 2 up front. So x plus 1 plus 1 over x plus 1. Plus some arbitrary constant, you're right, plus c.
The u, don't you have to get rid of the negative 2?
Yeah, I did. It became negative 1.
Yeah.
I added 1 to it, but then I had to divide by negative 1, so this minus became a plus. Yeah. So if I do the derivative, it becomes negative u to the negative 2. Okay, and there we go. Or it's 2 ln blah plus 2 over x plus 1 plus 2c. What's we gonna do? Okay, so the idea again, right? It's let's replace a binomial with a monomial, right? It's very easy to do the root of, but I got an x out front, so what's x equal to? And what's du equal to? Okay, so x, that's u plus 1. Root x minus 1, that's root u. Dx, that's du. What are we going to do? It's some kind of a product, right? We're just going to multiply it out. Because this and this, as individual terms, the sum of that, it's really easy to do. Really? Okay. Yeah, doing the anti-product rule, which we will learn eventually, doesn't make any sense in this particular instance, right? So this will be the integral of u to the 3/2 plus u to the 1/2. Brackets around that, right? Because it's the integral of that whole thing. You can split it up as individual integrals, or you can just do the integrals. So this will be 5/2, and then it's got to be multiplied by 2/5, and this will be 3/2. It's got to be multiplied by 2/3, and then a constant on the end. Oh, but it's not u. It's never u.
Yeah, read the message.
2/5. Hey, remember, this is being recorded. 4 minutes. I can't do it unless you guys want to stick around for a little bit. We just finished the last one. We're done. I'm going to finish it now. You can watch it on. I'll pause while you all leave after the bell goes, and then I'll just do it myself, and you can watch it.
Okay.
So I'm going to do it. You can stay and watch, or you can go. Like some of you have important appointments. Okay. You have friends to meet, things to do, places to go, people to see. Okay. At least if you see the start, it won't be so bad. Again, all right, I want to get rid of that 2 plus 2 root x. Okay? So we're going to do this. Let u equal 2 plus 2 root x, right? That's kind of nice, because now we just have 1 over u, and that's going to be easy, right? Because it's just ln absolute value of u for the integral. But what's dx? So du is so 0 plus that's x to the half, so it's 2 times a half times x to the negative a half, which will be x to the negative a half dx. All right, that's a problem because I have a dx, I do not have an x to the negative a half. in there just hanging around all by itself, which I can stick with this. So we got to do a little more work. And that little more work is we have to figure out what x is. Well, we got to do a couple of things here, I guess. So, well, actually, okay, what does that mean? It means that we have, so that's 1 over root x, right? So du is equal to 1 over root x dx. So root x du is equal to dx. So dx can be replaced by root x du. But I can't have x's in there, so I need to solve for root x. Well, okay, I can do that because I know that u is equal to 2 plus 2 root x. So u minus 2 is equal to 2 root x. So root x is u minus 2 over 2. Bringing this down, it means I have u minus 2 over 2 du is equal to dx. So this dx, oh, now if I'm going to do u's, then I should redo my bounds of integration, right? So here, just over here, we'll say when x is equal to 4, u is equal to 2 plus 2 root 4, which is 2 plus 2 times 2, which is 6.
Good morning, Wisewood.
And when x is equal to 9, u is equal to 2 plus 2 root 9.
It is 50 cents per shot, and you could have a chance to win some gift cards. And a reminder to all track and field athletes, there is a mandatory team meeting today after school in the South Docks gym. All track and field athletes must attend this meeting, and it will be followed by a mandatory team practice. And the Hector Wisewood badminton team wrap-up party is this Thursday after school in the main gym. Remember to bring your rackets. Thank you very much.
Okay, so we're almost there, right? I mean, the rest of you'll be able to do the rest of it on your own if you want to. So dx has been replaced with u minus 2 over 2 du. 2 plus 2 root x has been replaced with u, so 1 over u. The bounds of integration, when x is 4, u is 6, so we've got 6 to 8. So I have definite integral from 6, so I can pull out a 1/2. This is the half. I'm left with u minus 2 over u du. This is going to be 1 minus 2 over u. Okay, so the rest of it, and don't forget your 6 to 8 here. Okay, so let's finish it off. So 1/2 times, okay, so this is u over u, so 1 minus, well, it's here. 1/2 integral 6 to 8, 1 minus 2 over u du. So 1/2, so this is going to be u, that's a u to the negative 1, right? So it's going to become 2 ln absolute value of u. Evaluated from 8, 6, actually sorry, it's the 1/2 that multiplies that whole thing. Okay, so we have to evaluate it first and then, which becomes so I'm going to drop the absolute value of u because u is from 6 to 8. Okay, so it's 1/2 of this plus this. Okay, so we just got to plug in. Equals 1/2. Okay, so we've got 8 minus 6 plus 2 ln 8 minus 2 ln 6. So 2 plus 2, I'm going to factor that out, ln 8 minus ln 6. 1/2, 2 plus 2 ln of 8 over 6. Right, just combining, which is 1 plus ln 4 over 3. Okay, wait, somewhere back.
Why is it a plus up here?
Yeah, it's not, is it? It's a minus. All right, moving way up here. Minus, yeah, I couldn't have made the mistake the other way, right? Minus,
You're supposed to minus the
minus, 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 minus. You're in wise time. You stuck around for the beginning of wise time. It was really nice of you.
Why did you do it differently? When don't you do like you sub it